So look at number, I want to look at number 4. Skip number 3 for a second. Look at number 4. I would like number 4. I just love the idea that the farmer only knows the total number of legs of animals on this farm. He's a leg guy. So he knows there's a total of 62 legs. He knows he's got ducks and cows. What's the thing about legs and ducks and cows? How many legs does every duck have? 2. So you have to know a little bit of biology. Of course, cows have 4. We're going to assume they're all fine, that nobody had to lose a leg or something, right? It's kind of a big assumption to make, but you would think he would tell us if it was otherwise, being as interested in legs as he is. So when you have a word problem like this, now this is the way that some of you guys are trying to do the earlier word problems. I need you to understand, when we first did the word problems, there was a certain set of things you had to know how to do, that if you did this, you would never learn that other stuff. So some of you guys are already trying to use more than one variable before you should have. Now we know, officially we know how to deal with more than one variable. So watch how beautiful this is. What are my 2 unknowns in number 4? No, what do they mean? That's what's more important. Yeah, the number of ducks and the number of cows. You're my one blue. You're my one good marker, blue. So let me be crazy. I'm not going to use X and Y. I'm going to use D and C. Why the hell not? Right? So you can use whatever letters you want to, and you can make them make physical sense. There are 2 equations. There's 2 relationships in this problem. One of them is almost always the easy one. It's the total. It's the one where I add these 2 together and it gets something. If I add them together, what am I supposed to get? Yeah, 24 animals. For every duck, I get how many legs? 2. So what would that be? 2D. 2 times the number of ducks is the total number of duck legs. And every cow, of course, gives me 4 legs, right? So 4 times the number of cows is the number of cow legs. And if I add up the number of duck legs and the number of cow legs, I should get 62, right? So then again, which equation? Now there is something you could do with equation 2 in case you notice it, but just ignoring that for a second. Which equation is easier to solve for a letter? The first one, obviously, right? And you can solve for whichever letter you want to. What letter you want to solve for? D, okay. So to get D by itself, I'm going to subtract C. So now I know that D equals 24 minus C. That is nothing ground shaking, right? I mean, that's just saying however many cows there are, there's 24 minus that ducks, because there's 24 total. But how can I use this now? How can I use this information?
Plug it in for D in a second.
Yeah, plug it in for D, right? So now I can rewrite the second equation as twice D, which is 24 minus C. Twice D plus 4C equals 62, and now it's a simple, it's only got the letter C in the whole thing. Oh, sorry. Subtract 48. Right? Get your like terms together, move the numbers together, and then finally divide by 2. So what does this mean?
Cows.
Yeah, so the number of cows is 7. 7 cows. So how many ducks are there? Do it here. 24 minus 7, 17 ducks. So when it's a physical problem like this, it makes less, you don't have to write it as a point, because it's really not a geometrical idea, it's a physical idea. There are 17 ducks and 7 cows. Putting it as a point doesn't really help anything. So writing the duck-cow equations was probably not on your list of things you're going to do today, but that's what just happened. So, let me do this. No, I was going to do a little preview, but no. I feel like that's enough. Today was weird. Let's just put an end to the day. It's not raining at the moment, although I just jinxed us. Sorry.
Don't jinx.
It's too late. And we'll come back together next week unless we get an email saying otherwise. Yeah, so how would you graph y equals -1?
47.